This is a tricky question. It is given that the equation 2x cubed plus ax squared plus b equal to 0 has three non-zero integral roots. Two of them are equal. So if I assume the roots are alpha, alpha and beta, right? So summation of roots, which is 2 alpha plus beta, should be given by minus coefficient of x square, which is a, upon coefficient of x cube, which is 2, right? Now there is no term which consists x raised to the power 1 here, right? So if we take summation of roots taken 2 at a time, this gives you alpha into alpha plus alpha into beta plus beta into alpha should be coefficient of x raised to the power 1, which is 0, upon coefficient of x cube, which is 2. So it is 0. That means alpha square plus 2 alpha beta is 0, which is alpha into alpha plus 2 beta is again 0. Alpha cannot be 0, so that means beta is equal to minus alpha by 2. Now if I put this value in equation 1, I will get 2 alpha minus alpha by 2 is equal to minus a by 2. This gives you a is equal to minus 3 alpha. Similarly, if I take product of the roots, which is alpha into beta, which is alpha square beta, should be equal to b upon 2. If I put the value of beta here, gives you alpha square into minus alpha by 2 is equal to beta b by 2, that is b is equal to alpha cube. Now the value of a plus 3b is nothing but alpha cube minus 3 alpha, which is alpha square into alpha square minus 1, right? So we need to find a number. So beta is alpha cube, yeah. So a plus 3b, there is a mistake here. A plus 3 will come out to be 3 times of alpha cube minus alpha square. So this is 3 alpha into alpha square minus 1, which can be written as 3 into alpha minus 1, alpha, alpha plus 1. Now check the options. If I say the option A says that this value is 18. 18 gives you alpha is equal to 2. Okay. Option B, minus 18, gives you alpha is equal to minus 2. Option C is 72, gives you as alpha is equal to 3. And option D, 180, gives you alpha is equal to 4. Okay. How can we calculate this so easy is you can see that this term is nothing but thrice of product of 3 consecutive integers. So alpha minus 1, alpha into alpha plus 1. So you just need to take 3 common out of the options A, B, C, D and distribute them over the 3 integers, okay, the 3 consecutive integers. So these are the 4 values. Now we have to find which of these values is not possible. You can clearly see that when we say alpha beta is equal to minus alpha by 2, right? So and above it is given that the alpha and beta are the integral roots, that means beta has to be integer. For that alpha has to be a multiple of 2, but here alpha is not a multiple of 2, that means this case is not possible. So my right answer is C.